Hello, my name is Halia Shahri and this is my final project for cs50 Introduction to Cybersecurity. My research is titled When the Hacker is the Machine, the Rise of Autonomous AI Cyber Attacks. I chose this topic because artificial intelligence is becoming increasingly involved in cybersecurity operations, and I wanted to investigate how much control an AI agent can actually have during a cyber attack. Before looking at the case study, we need to define the main question. Can AI agents transform cyber attack from human-directed operation to adaptive machine-speed operations? This is important because using AI in an attack does not automatically mean the attack is autonomous. So, throughout this research, I will examine the difference between AI-assisted and autonomous cyber operation. An AI-assisted attack still depends heavily on human decision. A human may choose the target, set the object, and decide what the AI should do. An autonomous agent is different. It can reserve a goal, plan action, and admit its next decision. So the key question is not simply was AI used, the key question who was making the decision. An AI agent can operate through a continuous decision loop. First, it receives a goal and creates a plan. Then it perceives its environment, makes decisions, take in action, and receive a feedback. The important part is that the feedback can influence what happens next. In cyber security, this ability to adapt makes agents' systems particularly interesting. Now we can look at the real-world study case. In July 2026, Taiwan reported a cyber campaign targeting government systems in which artificial intelligence was used in convertible techniques. This makes the instance particularly relevant to our research. However, there is an important discussion. I should refer to the operation as AI-assisted, while security research report a much higher level autonomy. So we should immediately assume that the entire operation was autonomous. This brings us to the evidence. We can split the information into three: confirmed, reported, and uncertain. The use of AI-assisted techniques was reported by Taiwan's authorities. Additional details about autonomous AI agent came from security research investigating the operation. Therefore, this conclusion is not that we have proven a completely autonomous cyber attack. Instead, the investigation an operation in which AI played an increasingly active role. Traditional cyber operations rely heavily on human decision making. The attacker plans an action, observes the result, and decides what to do next. An agent system can potentially shorten this cycle. It can observe the results of an action and use that information to influence its next decision. This creates three major advantages for an attacker: speed, scale, and adaptability. This creates a new defense challenge. First, speed. Automated decision can happen faster than human can respond. Second, skill. One system can potentially perform many tasks. Third, adaptation. The system can change its behavior based on feedback. And finally, detection becomes more difficult. Defense needs to understand not only individual multi-actions, but partially the behavior of an automated decision-making system. So, how should organizations defend against these systems? My proposed model first focused on controlling the AI agent itself. First, the agent should have only the persons it actually needs. Second, high-risk action should require human approval. Third, its behavior should be continuously monitored for unusual activity. And finally, should be able to recover access or isolate the system if something goes wrong. The goal is to make the agent bonded, operational, and reserved. So the Taiwan operation was truly autonomous. Past of the available events, one can't confidently say that was fully autonomous. But we also cannot treat AI as simply a passive tool. The event is pointing toward a new middle ground, increasingly autonomous cyber operations. The important change is not necessarily that humans have disappeared. It is that AI can potentially make cyber operations faster, more scalable, and more accurate. The future of cybersecurity may depends not on stopping AI from acting, but on controlling what it's allowed to do. These are the methods I used for this research. Thank you.